Hey Josh, how's it going?
Hey, it's good. How are
Good,
you?
awesome. Doing fine, doing fine. Just enjoying the cold weather in Utah right now. So, where are you located?
I'm in Massachusetts at the moment. Yeah, so
Nice.
we there's I think still a bit of snow on the ground, which I've been out in California mostly for the past 5 or 6 years, so I'm not really used to it anymore.
Okay, well, welcome home. So, yeah, I think you're supposed to be getting a snowstorm tomorrow, so that'll be interesting. Maybe go for a mountain hike or something like that. So, well, cool. For those who don't know you, would you like to introduce who you are and what you're up to?
Sure. Yeah. So I'm Josh Tobin. I am I guess, recovering AI and robotics researcher. I spent most of the last 4 or 5 years working on machine learning research at OpenAI and at Berkeley, where I did my PhD. I was really focused on like intersection of deep learning and robotics, right? So how do we build robots that can learn from data and do intelligent things in the world that we don't have to directly program them for? Um, More recently, the problem I've been a lot more focused on is um, democratization of machine learning. So, in particular, I'm really excited about the progress that the research community has made over the last 7 or 8 years, and I think that the impact that that research is going to have on the world once we're able to productionize it is going to be huge. And so the thing I've been really focused on is like, how do we bridge that gap, right? How do we help most companies, most people take machine learning and actually use it to solve problems and build products and services in the real world?
What are your some of the initiatives that stand out in terms of democratizing AI right now?
Yeah, I mean, I think at a high level, I think that what when you think about like what was really hard in machine learning in 2013, 2014, or like 2015 when I got in the field, it was training models to solve a problem was really challenging, right? Like you had model architectures were evolving really quickly. The tools for training models weren't that mature yet. And so, a lot of the effort in the field went into like, okay, I need to keep up with state of the art. I need to make sure that I'm always learning the latest tools. I need to like do a lot of math and think a lot about like neural net architectures and stuff like that, because that's what you need to do to solve problems. Um, and data has always been a challenge, but I think like the biggest thing blocking companies was like, how do we even assemble the right set of people that like know all of this like crazy esoteric knowledge that they need in order to build models to solve our hard problems. Um, and I think at a high level, like one of my beliefs about the field is that we're kind of at the point where you know we're going to look back on this moment 5 years from now, and it's going to seem crazy that people were spending so much time thinking about that. And we're going through that transition right now, where it's like the process of actually building models to solve a particular problem is becoming commoditized. Um, and happy to talk about some of the forces that I think are causing that. But uh, yeah, and so I think like the big challenge for the field is like, okay, what's next? Like, if training models is easy, then like, what do we need to move on to from there?
It's interesting. Yeah, what are some of the forces that are driving sort of the simplifying model training?
Yeah. So I think I talked a little bit about pace of research. I don't think the pace of research has like slowed down per se, but in a lot of subfields of ML, the kind of rate of progress is not as frantic as it was, 5 or 6 years ago. So what that means is that, if you were working on computer vision in 2014, you basically like if you wanted to keep up, you needed to implement a new neural net architecture every like 3 or 4 months because there was some paper that was coming out
I remember that.
state of the art. And now it's kind of like most practitioners and I know just basically use like ResNet or like a simple variant on that. And that's been the same since like 2017, I want to say 2018. And one of the factors is that like the rate of algorithmic progress on a lot of the sub problems in ML that people really care about is slowing down. Um, a second factor that I think is causing like the commoditization of model building is that architectures themselves are starting to converge a little bit, right? So, I mean, we kind of talked about like in computer vision, ResNets have taken over a lot of the computer vision use cases that used to have like bespoke architectures. In NLP, something similar is happening with transformers, right? And a lot of people in the ML world believe that transformers are on the verge of taking over computer vision as well, right? And so I think the space of like architectures that make sense to try for a given problem is starting to narrow. So that's a second factor. Third factor is that the tools that we have to train models are just getting better and better, right? Like, the first tool that I used, well, the first two tools that I used to train neural nets were Caffe and Theano, right?
Oh yeah,
Yeah, and I
it's old
was lucky
school.
to have those tools, right? Like people who were, even just like a few years earlier than me at Berkeley, like the PhD students were developing Caffe, right? So, but if you look at the tools that are available now, like PyTorch, JAX, PyTorch Lightning, the rate of progress of GPUs, TPUs, how easy it is to do distributed training now, like it's the stuff that used to take like months and months of engineering effort is something that you can just like spin up and run right away. So we have access to a lot more powerful models and compute just like right at our fingertips. Um,
Hmm.
and I think like, so that's maybe the third factor. And then the fourth is that I think auto ML is starting to work. So I think like when I used to think about auto ML, it was just sort of this, it seemed like kind of a pipe dream, right? Like this kind of naive idea that you could create an algorithm that would automate all of the work that machine learning engineers spend all their time and effort doing. But I think with increased compute, a lot of these techniques become more feasible. And as like subfields of ML mature more, right? So recommender systems or computer vision or NLP, I think we're going to start to see auto ML tools for those particular like subfields of ML start to actually get really good. And then the fifth trend that I would point to is the emergence of these like mega APIs, right? So I think GPT-3 is the best example of that right now. And it might be the case right now that if you want to solve any NLP problem, the best possible, like the most feasible way to do that is to like find a way to get a GPT-3 like access token and then apply GPT-3 to your problem. And I think that like more and more ML use cases are going to start to get eaten by mega APIs. And so, like the trends being like slowing down of progress of algorithmic development in some of the key ML subfields, convergence of model architectures, improvement of tools, like better access to training tools, emergence of auto ML, and like mega APIs starting to eat more and more use cases. I think if you look at those five things together in the not too distant future, the idea that like most of the people in the field are going to be spending their time thinking about training models feels maybe a little bit outdated.
Right. I mean, do you envision sort of a feedback loop then from a mega API to a business problem and back again, or what are your thoughts on how that would start speeding up maybe some of the parts that are languishing right now?
Yeah, I mean, I think the challenge for the mega API developers is going to be how do you build the user experience in the right way so that you're not just stuck with what you get off the shelf. And I think one of the powerful things about the GPT-3 and the demos that people were able to create with it was that the breadth of things that you can create off the shelf was like crazy. At least to me, right? It was just mind
Yeah.
blowing to see it generate code and do all these other amazing things. But I think what companies that are trying to deploy GPT-3 are realizing or are going to start to realize is that like there's still a lot of corners to be smoothed out in terms of actually like building that into a good product experience for their users, right? And so I think if OpenAI and the other companies that will inevitably end up developing mega APIs for NLP and vision and other subfields are able to figure out like a really nice experience where you can take GPT-3 and you can start to tailor it to your use case without necessarily being a deep expert in how these systems work, then I think that that's going to, those types of APIs are going to start to eat into the rest of the ML world more quickly.
Right. That's interesting. And I think you bring up an interesting notion I've been thinking about a lot too, which is um, I think as ML becomes more pervasive in business, what does it do to existing business processes and how do those change? Whether blatantly or I guess more from an evolutionary standpoint. I don't know if you have any thoughts on that, but
Yeah, I mean, I think before I was in ML research, I was in a previous life, I was a management consultant. And so, my job was to
nice.
work with, companies outside of, for the most part, like outside of the technological leading edge. Um, and, one of the things I realized from doing that was that the way that most companies operate right now is not even like really fully caught up, I think, with what is possible to do with software, um, let alone with machine learning, right? And so, give you an example. We were working with a bank, and part of what we were trying to do is like map out the operational processes that the bank had, so that they could be more efficient, right? And so we were interviewing people that were part of this process, asking them about like how they do their job, what they what their output looks like, who they hand it off to. And so we were talking to one person, and he said, and we were like, oh yeah, so tell us about like how you run this part of your process. And he said, oh yeah, like it's easy. Like I get an email, and that email is like a PDF, and then I open the PDF, and there's a bunch of numbers in that PDF, and so then I open the spreadsheet, I type the numbers in the spreadsheet, and then I print out the spreadsheet, and then I walk down the hall that way, and I take the stairs on my left, and then I walk down the hall the other way, and I like use the first door on my right, and I put this printout on like so and so's desk, and like that's my process. I think that like people in the tech world don't realize like how much of the business world still operates like that to a certain extent. And so I think that's like both the challenge and the opportunity for machine learning in industry, right? Is that like the challenge is that how do you start deploying a machine learning system in a context where a lot of the primitives might not be in place, right? Like there might not be heavy digitization. There might not be like really good data infrastructure. But it's also an opportunity because like so much of the way that the goods and services that we consume are produced is just really inefficient. And I think that like that's to me that's one of the most underrated promises of ML, right? Is it's like everyone talks about self-driving cars and real-time translation and stuff, and those things are great, and like hopefully that works and that'll be amazing. But I think there's a long tail of applications of machine learning and AI that just involve like taking something that is really manual or requires a lot of sort of repetitive judgment and augmenting the way that people do their jobs to make those things more efficient.
Yeah, I can fully echo that sentiment and those observations. I mean, in the business that I have, I mean, as you call yourself a recovering AI researcher, I mean, I call myself a recovering data scientist for much the same reason, maybe the same reasons, I don't know. But the things I noticed were companies were trying to do machine learning, right? And maybe it wasn't so much that the implementation of machine learning, I think a few years ago, especially was interesting to watch for businesses because it was more, I think, FOMO driven, kind of fear of missing out than maybe an actual business use case. And when you start digging into the infrastructure and the data of these companies, you typically find that the data is probably not going to yield much in the way of much useful training data, for example, right? And you also come to find out that the analytics is probably in a pretty miserable spot too, because it's usually like, well, it's all up here, right? Like I know my business, and Susan down the hall, she knows the other piece of the business. So I think we're pretty good, but can you give me some speech recognition or something? So that was what we typically run into. Yeah, so I totally agree. It's pretty fascinating, I think, especially when you realize like things like cloud adoption, for example, right? They're still super early. And the amount of companies that still need to move to the cloud, get their software into the cloud is still, I think, 20% or something like that, maybe 25, depending on who you ask. But it still seems like it's very early days. So yeah, I definitely echo what you observed. So
Yeah. Yeah. I mean, there's a lot to do, but it's I don't know. That's part of what makes it so exciting for me is that like um, I think it's easy to look at the world. For those of us who are based in Silicon Valley or who have like ties to the technology industry, it's easy to look at the world in terms of like where how fast is the bleeding edge moving, um,
mhm.
and that's a really interesting lens through which to look at the world. But the in terms of like the impact that the technologies that were developed in the last 10 years are having on the world, we're still in the early days. And so that makes me really optimistic because, all of the like productivity gains and efficiency and like capabilities that, cloud and data science and machine learning and all these other technologies are going to have, even if we don't see, that starting to happen on the bleeding edge, there's still a long tail of backfilling that needs to happen.
Hmm. And I guess when we speak about democratization, where does education fit in to democratizing ML?
Yeah. So I think one of the interesting things about machine learning, from my perspective, is that it feels like the education in the core, math and algorithms behind ML um, got really, really good very early on in the life cycle of the technology, right? I mean, I think in ImageNet, AlexNet, 2012, 2013, right? I started learning about machine learning in 2015, and I was already learning from, Andre Karpathy's Stanford course, right, which was like a great, great class, and I think had a big impact on a lot of people who were learning the technology at the time. Or Andrew Ng's class was like another thing that I looked at early on. And I was like I wasn't super early to ML, but I was relatively early to it. And sorry, let me just turn off my Slack. Um, and to have access to great education like that was, I think, maybe not something, looking back on it, that I would have expected to have in a field as new as machine learning was at the time, or at least still as emerging as machine learning was at the time. Um, so I think that I think that having that, like, the acceleration of the number of people that know how to do ML at a, at least at a basic level, has been pretty staggering to me. Like, I think there's, at Berkeley now, the undergrad machine learning class has, literally thousands of students in it. Um, so on one hand, I think the field is doing like really well on education, and like lots and lots of people are learning, uh, have been able to pick up this technology really fast because people just cared about teaching it well early on. Um, on the other hand, I think that there's still really big gaps in the world of machine learning education, and I think that most of those gaps are around um, everything else, everything else other than learning about neural networks and learning about back propagation and learning about TensorFlow and Keras and PyTorch. Um, and in particular, I would point to kind of three areas that I think are still missing, right? So one is teaching executives about machine learning. So in a lot of companies that I've talked to, really common complaint is like, hey, we're like launching this machine learning initiative. We've hired some really good people, and like we think we're making progress, but progress is slow because it's machine learning and it's kind of still science in some ways. But like our executives just don't really get it. Like they don't understand why we're not shipping stuff on on a regular schedule, and they don't understand why they can't just like throw twice as many people at it and have it go, twice as fast or 1.5 times as fast. And they fundamentally just don't really get what makes this technology different than, maybe the software that they're used to building. So I think that there's still a big gap in terms of like explaining this technology to folks with more of a business background. And in particular, like not just explaining like, what is machine learning? Like what does it mean to say like a model learns from data, but really educating them on what's possible right now and how these projects actually get done. So that's, I think, one big gap. Second big gap, I think, is like educating folks that are like, let's say technical or like non-technical, but who, are able to like get stuff done through software, but who don't and aren't going to have a machine learning background, right? Like I think, to your point of the earlier discussion, right? Like it's possible to do a lot in ML just through APIs right now. And I think it's a lot of that is stuff that you can just pick up by trying it. But I think that there's some like core mindsets that would be really helpful for folks like that to have. And so I think like a semi-technical intro to ML, right, where it's like taught at a conceptual level. You don't need to implement neural nets. Like you just need to kind of understand how these things work, is still missing. And then the last like gap that I'll point to, which is the one that's kind of nearest and dearest to my heart, is teaching people about the engineering side and the operational side of machine learning, right? So if you're a team that's like trying to build machine learning enabled like products and services, you need to know how to train models, but there's a lot of other stuff that you need to know how to do too. You need to know how to like pick the right projects. You need to know how to scope those projects. You need to know how to like manage a team that has engineers and ML people on it. You need to know how to write good tests for your ML code. You need to know how to like deploy stuff, how to monitor it, how to, and how to improve your models over time. And something that I've been trying to teach people about for the past couple of years. And I think there's still a long way to go in terms of like having a really good educational core around it.
Yeah, in fact, I checked out your what was it, your full stack machine learning course, some of the videos on that, and I thought those are excellent. I've actually, in fact, started suggesting these videos to people who are interested in like ML engineering or MLOps. I think it was a very comprehensive syllabus, I would say, for somebody who wants to know like all the other engineering stuff. So kudos on making that, by the way.
Yeah,
Can you walk me through like what was that like a class that you taught at Berkeley or like a seminar or and like how did that all come about?
Yeah, so a couple of years ago, I was at OpenAI, and OpenAI was kind of transitioning, right, when from in terms of what kind of organization it is. So when I first joined, there were around 20 people, and I don't know, maybe half of them were like current students or recent grads from Berkeley, and like probably half or 2/3 of the people there had a PhD. It felt like it very, very much felt like a traditional academic lab, but with a lot of funding and press and hype and all that stuff. And then if you look at OpenAI now, it's really different than that, right? It's kind of it's a pretty unique organization in that like it's a research organization, but it's able to work on these like larger scale and more ambitious projects. It's starting to have like a bit of a hand in developing products themselves. And so as that change was happening, there were a lot of things that we were trying to figure out as an organization, right? Like, at the core, like how do you professionalize the process of training machine learning models, right? Like how do you work on models as part of a larger team with bigger budgets? How do you like manage those teams? How do you write good tests for your machine learning code? And so around that time, I was talking to my advisor at Berkeley, who was running a robotics startup, and another friend of ours who was running this machine learning enabled education tech startup called Gradescope. We're kind of swapping notes on some of this stuff, and we had this realization, right, of like, that this education gap that I was alluding to, where it's like, there's great resources for learning the math and the algorithms and the code behind training neural networks, but there at the time, like, very few people were talking about the engineering side and the operational side of it. And so we thought it'd be a good thing for the field if we sort of wrote down everything that we knew about this, and everything that our friends knew about it. And so we decided to create this course, and we set it up as a boot camp that we ran at Berkeley. So we brought like 150 or so people at a time out to Berkeley, mostly practitioners, but a mix of mostly like grad students as well, and did like a 2 or 3 day like super intense crash course on all this stuff, where people would show up at 8 a.m. like lectures would start at 8:30, and then we would all like go out and get a drink at like 9 p.m. after the lectures were done. So it was like really, really intense, and people learned took a lot away from it, but it's clearly just like not the right format to teach that material in, which it was mostly just a constraint of like our time at that point, right? Like we all had full-time jobs doing other stuff, and so we were like, okay, well, if we squeeze this into a weekend course, it's easy for us to do it, and it's easy for people to like take time off of work to do it. But I think that like part of the evolution of the course has been starting to think about like, okay, we have the core of some of the material that we think people need to learn in order to be good at this stuff. But what's the right way to actually teach that material?
Mm-hmm. That's a really good question. Part of me wonders, I also teach at a university, and part of me wonders if that could be a full semester length course.
Yes, we're doing that. We have a semester length course at Berkeley.
Nice.
This year. Yeah.
Perfect. That's great. Enrollment, I imagine, is probably pretty good. Are you going to get a lot of interest in that?
We're capping enrollment to 50 because we want to try making it very project based. So
that makes a lot of sense.
It's a practical course, right? Like, we're not teaching people a lot of theory. There's not a lot of math involved in the course. So really the right way to demonstrate that you've learned this stuff is to build like a project that has ML embedded into it, and ship it. And so we want to make sure that we're setting things up so that people will be able to like make really, really cool projects.
We're
hoping that
it's really cool though.
Yeah. So that's why we're
yeah. No, that's going to be awesome. I mean, is it going to be online as well for other people to view, or it's going to be kind of closed off? Okay, that's awesome.
You're going to release all the lectures.
Yeah, I think the project base is definitely the way to go for a lot of these types of classes, especially when, like, I don't know about you, but I get hit up by students quite often where they ask, okay, so how do I get a job in data science or data engineering, for example? And one of the things I always ask is, well, do you have any projects that you can point to that you've worked on? And I think ML engineering is very unique in that sense, where there's, even to this day, there's not a lot of good reference material at all. Your course may actually be one of them that I think is more canonical, but you start getting into even Safari books or textbooks or something. It's not like there's, if you go into the algorithm space with like hands-on PyTorch, TensorFlow books up the wazoo, I mean, you can spend like 100 years reading all that. The ML engineering, MLOps side, it's quite a different story right now. And projects would be the one thing I'm glad you're focusing on that piece too, because for any class that I do, it's definitely like show what you can do, not just regurgitate a formula or something that you found on Wikipedia. So
yeah, I mean, I think you have to tailor the format to the material, and I mean, I've taken a lot of math courses in my life, so I have no problem with that way of teaching either. It's just not the right way to learn the stuff that we're teaching.
Sure. And I guess on that note too, like what's some advice you would have with somebody who's, maybe we'll start with data science, who wants to get a career in data science in say 2021? What would be some advice you'd give sort of a new entrant to the field?
Yeah, I think two things. I would try to narrow the scope a little bit of what you're looking for. So I think one of the problems with data science as a field is that the term data science is just completely overloaded at this point. Um, and so in some companies, data science means like data analyst, right? Where you're working with data that's in a warehouse. You're running a bunch of queries to understand that data. You're producing reports. Um, and in some companies, data scientist means someone who is training machine learning models as part of their job. And in some companies, it means like really someone who does more data engineering stuff, like is trying to get the data and spends most of their time getting the data into the right format and in the right place. Um, so I think narrowing down what you want a little bit is one thing that I would do. Um, and the second thing that I would do is I would consider whether you like which part of that stack you really want to be working in. And I think it's really tempting to think of, the machine learning piece of it as being kind of the exciting thing to do. And but I think that like a lot of people who get into that field eventually realize that that's not really where most of the value is going to get created. Most of the value gets created in the less sexy stuff, right? Like the data engineering side of things and the data cleaning side of things. Um, and I think, right now, like status and prestige and compensation doesn't really reflect that. Although really good data engineers, that's a very lucrative career to be in because they're really hard to find. Um, but I think over time, as training machine learning models gets commoditized, I think the field will like compensate to reflect that. And I think that if you build a skill set entirely in modeling, it's not that you won't be able to find a job in 5 years. Like those jobs will always exist because there's always going to be a need for building bespoke models. But I think that the fraction of the pie that goes to modeling is going to get smaller and smaller. So I would consider like whether you really, really want to focus on like training models and doing more research oriented stuff, or whether your goal is like more around the impact that the that data science has on the organization that you're part of. And if that's more of your goal, then I would say like focus more of your effort lower in the stack.
Makes a lot of sense. I mean, kind of looping back to your notion earlier about democratizing AI, where do you think democratizing data engineering and machine learning engineering fits into that picture?
I think it's like the key challenge in the field right now. Um, I think when I look at the field, like, if you think of data engineering and ML engineering as being distinct from modeling, which maybe is not the best way to split up the world, but like for the sake of argument, let's do that. Um, I'm much more confident in the trajectory that modeling is on for, becoming democratized over the next 5 years than I am about the other two parts of the field. Um, so I would say, if your goal is if you really care about the impact that machine learning is going to have on the world, then I would focus your efforts. I wouldn't focus your efforts on democratizing training models because it's going to happen whether you do it or not. Like someone's going to do that.
Right.
Just there's so many smart people working on it. But unless that's coupled with democratization of like ML engineering and the operational side of deploying and maintaining and continuously improving models and data engineering, then the impact of like having really, really good low code auto ML tools is going to be pretty minimal.
Right. And I guess on that note too, what are some of the challenges that you see in productionizing models and sort of the post-training realm of machine learning?
Yeah, I mean, I think it's all challenges right now for most companies, right? Like I think most companies are really struggling with this. Um, I think if you think about the different components of post deployment, right? Post training, right? There's like testing. So like, how do you even know if this model is ready to go into production? And there's deployment, right? So it's like nuts and bolts of how you feed data into the model and get predictions out the other side. And then how you like manage updates to models over like pipe updates of models over time, like how you gradually shift traffic over to new models. There's monitoring, right? So understanding right now how well is my current production model doing. And then there's kind of like retraining and active learning, right? So how do I know when I need to retrain my model, and how do I know what data set I should be retraining it on? And I think that there's lots of challenges in all of those areas. So, which is good if you're excited about working in those areas. I think, I would say that like the ones where there's probably the biggest gaps is monitoring and like the active learning and retraining piece. I think that most companies that are relatively far along in their ML development have already figured out ways to test models and to deploy them. But even at like some very, very, what I would consider very top tier ML companies, when you talk to them about monitoring and when you talk to them about retraining and selecting data sets to retrain on, it's still something that they're figuring out.
That's really interesting. Is there any particular area that you're specifically focused on or very interested in right now?
I'm interested in all of the above. Yeah.
All the things.
Yeah. And so, yeah, I think I don't want to go into details quite yet about which particular part I think makes sense to work on first. But
yeah, that's awesome. Yeah. I mean, what are some resources where people could get an understanding of maybe some best practices around the hardest parts that you mentioned, like monitoring or active learning or retraining?
Yeah, I don't think that there are really great resources.
Okay.
I would recommend, I think like, I would plug our course, which is free. So I don't feel bad about plugging it.
Right.
At course.fullstackdeeplearning.com. I think honestly, we don't really do a great job of those topics either. And part of that is because I just don't think there are very well established best practices there. So another thing I would recommend is taking a look at some of Andre Karpathy's talks about how they approach some of these problems at Tesla, because I think they've been very thoughtful in sort of pushing the boundaries of what kind of how far we can go with those parts of the problem.
Yeah, that's interesting. I mean, do you have any favorite machine learning projects that you've worked on that you want to call out?
Yeah, I mean, most of my PhD work was on using simulated training data to make robots that can work really well in the real world without needing to gather a bunch of real world training data. So that's kind of, I still think that's a very underrated idea in robotics. So I think I would love to see more people work on that. And I'd point you to some of the OpenAI blog posts around manipulating objects with a dexterous robot hand.
For something like that, like how much synthetic training data is required to train a robot to function properly?
A lot. But it's kind of like the wrong question, because the whole point of synthetic data is that it's like very cheap, right? It's like
right.
Essentially like basically zero marginal costs. Whereas like real training data, particularly in robotics, is really expensive to get, because like think about if you think about like what kind of training data you need to get to solve a robotics task. It's like data of the robot doing the task. And so how do you even get that if the robot doesn't already know how to do the task? And like generally that involves like having a human demonstrate it on the robot, or having the robot try and fail to do it many times through reinforcement learning. And robots are not very scalable and parallelizable. So it ends up being like very slow and expensive to collect all the data that you need. Um, and so the point of simulated training data is that like your data is much lower fidelity and much less representative of the actual task that you care about. But it's also like way cheaper. So if you can use like hundreds of millions or billions of data points, and it's expensive because that's a lot of data, but it's still cheaper than gathering that much training data from robots that cost $100,000 each.
Yeah, that's a good point. Because you don't want to like run a robot off a cliff or something to see if it could fly. So
Nope. Ideally not. Yeah.
yeah. On the synthetic data use
Robots is a
case,
healthy part of the robotics research process. I think
right?
if you do like a PhD in robotics and you don't break any robots, then I would say like, are you really pushing the boundaries hard enough?
That's a good point. On the synthetic data notion too, do you see any applications of using synthetic data in a business setting for machine learning?
Um, yeah, I mean, I think anywhere where people are using computer vision right now, I think they should be considering synthetic data. Um, won't be useful in every single use case, but I think it's more useful than people give it credit for. Then I think there's another notion of synthetic data that is maybe more broadly applicable in the business world, which is like synthetic data in the sense that you train a model that represents a data distribution that maybe is private or you're not allowed to actually look at the data from, and then using that as a proxy for that data. So it's kind of also termed synthetic data, but means something like pretty different. And I think that type of synthetic data is pretty broadly applicable because data privacy is a huge challenge for like actually making machine learning systems work in the real world.
As we kind of zoom out, I mean, what are some of the things that could, and this is for in a business context, but what are some of the things that you think could actually stall the progress of machine learning adoption?
I think that we're at a pretty pivotal moment in the machine learning adoption curve, where the glory days, right? 2016, 2017, machine learning was like the hot thing, right? Someone once told me that IBM Watson spent $1 billion on marketing, and I don't know, I haven't verified that figure, but it wouldn't surprise me, right? And so the upshot of that is like, it's 2017. You talk to like any executive of a big company, and you ask them about AI, and they're like, "Oh yeah, like big strategic priority for us. This is the future of our business." Slight exaggeration, but I think like maybe not too big of an exaggeration. And the implication of that is that like there's a lot of kind of blind funding of machine learning projects, where it felt like a bit of an arms race, and companies were willing to say like, okay, yeah, we don't really fully understand what this is yet, or what it can do, but we know that it's like our board is putting a lot of pressure on us to do it, or like all of our competitors are doing it, and so like we're going to invest in this. And so you have a lot of companies that went out and started to build machine learning teams, and took a couple of years for those machine learning teams to sort of form and figure out what problems within those companies were actually worth solving, and to get kind of good enough at like accessing the data within the organization and figuring out how to train models on that data. And so I think where a lot of companies are at in terms of machine learning is like they made the investment, they have a team that is producing models, but the company is not actually getting a lot of value from those models yet. And so I think it's kind of like a pivotal inflection point for the like near term adoption of machine learning in industry, because I think there's going to be a bit of a reckoning over the next few years where companies start to look at these efforts and say, hang on a second, like, someone told me that this is going to transform my business, but I actually don't see any value from it yet. And it's really expensive. So what are we doing here? Um, and I think that, there's sort of two possibilities, right? Like one is that the field is going to step up, um, and start to figure out how to actually use machine learning for the things that, it's promised that they will be able to do, right? Like being embedded in products and services, and like making those products and services better and more efficient and more automated and more personalized. And then the other possibility is that it won't. And I think that I don't think that'll stop the adoption of ML in industry. I feel like that's pretty inevitable at this point, but I think it'll slow it down. Um, and I think like what we need, like what the field needs to do in order to sort of rise to that challenge is two things. One is that I think the field needs to change a little bit. So I think that there's kind of like the other side of the coin of ML being this like thing that everyone did without scrutinizing for so long, is that like a lot of people in the field were kind of came up with that mentality as well, right? Where it's like there's this sort of there's like the caricature at this point of the like prima data scientist who's just like they're like, my job is to train models and you pay me a lot of money to train models, and so like I'm not getting my hands dirty with anything else, because like I'll just go get a job somewhere else and they'll pay me even more money, and I'll do less like real work. And there's a lot of folks in the ML world who like don't have facilities with like really basic tools from the software engineering world, right? Like I was talking to someone who's like the one like software engineer at a startup that was like mostly PhDs, and their job was kind of like trying to corral these PhDs into like actually doing useful, like making the machine learning work that they're doing useful, which is a very unenviable position to be in. But he was telling me that like he was having trouble even convincing the like ML folks to use Git, right? And I was just like, listen, like if your ML team is not using Git, you have bigger problems than like tooling is not your problem, right? Your problem is like maturity of the discipline that like your ML engineers are practicing. So like one thing I think that needs to happen is that the field needs to grow up a little bit. Folks need to like ML people need to absorb a little bit more software engineering knowledge than they have right now. I'm not saying that every ML engineer needs to become an amazing software engineer, because I think that's just unrealistic. But some of those practices need to start to carry over. And then I think the second thing that's needed is just better tools for productionization, right? Like I think tools around ML productionization are like 10 years behind they are for software productionization. And on top of that, like since ML folks have a lot less maturity around how they are able to do software engineering, those tools don't need to be like 10 years behind. They need to be like 5 years ahead, right? Like they need to be an order of magnitude easier to use and more capable than the tools that software engineers use to do their jobs. So I think those are like, I think both of those things need to happen in order for ML to keep like riding the curve in industry that it's riding right now.
Those are really good points. Yeah, I completely agree too. These are the same things that I'm saying. I was just talking to somebody the other day about software engineering and machine learning. I think somebody was asking like, how do I learn how to code as a data scientist? It's like, well, there's a lot of good books you could read. I mean, the old classics like Pragmatic Programmer, Clean Code, like the canonical things. I would say just start there. If you want to learn software engineering, go learn software engineering, right? Like, but I think as you correctly point out too, you're not going to be great at everything. I know I'd like to see if you're a data scientist, at least being able to use Git would be a good step for sure. So
seems like a pretty basic step.
Yeah. And just, like understanding when to use functional and object-oriented programming, for example, right? It's interesting. I guess to close out, like, where do you see things going? And we don't sort of touch on this, but like in the next 5 years, everything works out perfect. Like, where do you see the world of ML and AI?
Yeah, I mean, I think we've touched on a lot of these points, right? But I think, the meta point is that I think there's going to be a lot more structure and organization to like how teams approach solving machine learning problems in the context of like trying to get ML embedded into a product or service that their business is creating. So there's going to be a lot more organizational maturity, I think the field will be more mature in the sense that like people are going to, know that are going to come up expecting to do a little bit more operational work than they do right now. I think the tools are going to be a lot better across all parts of the stack. And I think that there's going to be, and I hope that in addition to that stuff, like kind of the long tail of ML applications, there's a few big wins from some of the more ambitious projects around autonomous vehicles and NLP and those sorts of things as well.
Yeah, that's awesome. So what's a good way for people to find out more about you?
Yeah, I guess just follow me on Twitter. I don't know, or check out my Twitter. There's links to other stuff there.
Nice. Awesome. That's I guess at Josh Tobin.
Josh _ Tobin _. Yeah.
Okay. 2 underscores. One
Two
Josh,
underscore.
one Tobin.
Yeah.
Okay. Right on.
The first Josh Tobin on Twitter, I guess.
That's cool. Well, Josh, it's been a pleasure. Thanks for your time. So
Yeah, thank you. This
we'll
is
talk
fun.
to you soon. Yeah.